All right, so we'll get started. Again, welcome to Apply Day. This is the SigmaNEST Software by Cambrio presentation. I'm joined by Brian Blair today. So before we dive in, I just want to give a quick background of applied engineering. For over 35 years, Applied has been helping companies overcome engineering challenges, whether it be with our technology team, providing training, implementation, and support for our software and hardware solutions, or our services team providing design and manufacturing engineering, as well as software development and reprographics. We fit your needs. So with that, I will turn things over to our presenter, Brian Blair.
Thank you, Emily. Once again, my name is Brian Blair. I'm the Director of the West for Sales for SigmaNEST by Cambrio. It's a real pleasure to be here today. And first off, I want to thank Applied Engineering for allowing SigmaNEST to be a part of their solutions they're providing and the information that they're providing to their customer user base. Times are changing and we need to have more awareness on these types of products and services that are available, and these types of events are extremely important. And once again, we thank Applied Engineering very much so for having us be a part of that. A little bit about a background of myself real quick, not to bore you, but I've been with SigmaNEST for about 26 years now, I think. And prior to that, I worked in a large steel service center using different CAD/CAM systems and programming many large gantry style, high volume pieces of equipment. So I've had quite a run as far as the industry is concerned, and have had the pleasure of visiting thousands of shops during my time here at SigmaNEST. A little bit background on SigmaNEST itself. We've been around since about 1992. At that time, it was called SigmaTech, and we're the developer of SigmaNEST. Recent history developments, SigmaTech was purchased by Battery Ventures back in, I believe it was 2019. And we recently acquired two other companies, Cimatron and GibbsCam, to form what I call the triple crown of software in Cambrio. So we have Cimatron that provides a hard tooling software, and GibbsCam that does a lot of the advanced milling and turning software, and then SigmaNEST that does the high volume plate fabrication as well. So it's quite a nice complement, and we're excited to bring these companies to the user base out there. But today I'm going to be focusing mainly on SigmaNEST and a few of the auxiliary products wrapped around SigmaNEST that are taking us down the road to further process improvement. We've got a pretty substantial footprint globally. We are a global company. We have headquarters and development offices and reseller offices all over the world. We probably got over 25,000 licenses. The slide's a little bit dated on that, but so we have a substantial customer base throughout the globe and support mechanisms throughout the globe as well. When SigmaNEST started, it was all about just programming for the machines. Advanced CAD/CAM was kind of really what we did, and we did a really good job at that. But what we found is we really just moved the bottleneck. We moved the bottleneck from programming, and we pushed it out on the floor. And then the bottleneck sat out there, and how they had to administer these nests and take care of these parts and facilitate all of this after the programming process, that became the new bottleneck. So what we've done in advance throughout the years is created systems and processes and applications so that we can move this bottleneck completely out of the manufacturing and process sector by providing, shop floor management tools and business integration tools, which I will show you, and we'll go through some of that today. So as far as SigmaNEST is concerned, we've always kind of preached the 5 M's of it: material, motion, manpower, management, and machines. We don't find savings just in material. Material is the real easy, tangible one when you're using nesting software. You know, how much material are you saving? What is your scrap percentages? Things like that. We provide substantial savings in that, obviously, and we're a leader as far as nesting technology is concerned. I think that's pretty much undisputed. But we also find these savings in other areas, you know, like motion, creating better tool paths, more efficient tool paths, less piercing, just a more intelligent way and safer way of running these machines, especially since they've become faster and more efficient and things like that. Then we have manpower, just making a software that's very easy to work with and very easy to cross-pollinate to other equipment, you know, providing and requiring less training, less personnel to facilitate all these programs and things like that. Management and then the machinery themselves, you know, to run one programming system across the board for all different types of processing equipment. In today's market, you know, 15 years ago, 20 years ago, however, it was okay to buy a machine and it comes with its own software, and before you know it, you have 2 or 3 different color machines in your shop, and you've got 2 or 3 different pieces of software to run them with, and that was okay then. But now we need to be looking a lot further ahead than that in what our capabilities are going to be, how we're going to streamline these processes. Do I want to integrate to business systems? Do I want to have, you know, what type of shop floor connectivity do I want to have? And they want to be able to run all this equipment with one piece of software, one solution, you know, one training, one, you know, support, that type of thing. It just makes the most sense to operate in that fashion. So we really strive hard to put together this type of environment that makes a lot of sense for process improvement for fabricators. SigmaNEST itself, it obviously has grown. You know, it used to be, I always use the pizza analogy. It used to be one slice of pizza. Well, now we're pretty much an entire family-sized pizza with 16 slices. So depending upon what solutions that a company needs, we have the teams and the phases of implementation that we go through to make sure we can implement these in a timely and coordinated fashion. So most of our customers start out with basic programming in SigmaNEST, you know, importing of 3D CAD, things like that, and just programming the machines. That's really a phase 1 type of solution. Then we get into what we call, you know, work order management, inventory control, and quoting. This obviously brings up a whole new list of integration opportunities, of which we start looking at phase 3 and phase 4. Phase 3 really being the integration to the business system, the MRP, ERP, through our SimTrans product. And then phase 4 is where we do a lot of our shop floor control and feedback applications. So it's very methodically, the system's very methodically thought out and implemented. We've got a large customer base, as I mentioned, and obviously customers that you see on the screen here, very large customers. You know, a 0.5 percentage point of savings to these guys is an incredible amount of money across the board in all categories. So they put a lot of effort and actually expense in researching and determining the best solution provider for them in this arena. And they've chose SigmaNEST products for that. And we're pretty proud of that. Now, while these guys represent 30% probably of our business, the other 70% are your standard companies, you know, your one to 5 machine shops, your small, mid-range companies. We have solutions across the board for all types of sizes of customers and things like that. So the idea, one system to run all machines, you know, one software to train, very easy to cross-pollinate across the different pieces of equipment. Even in the more advanced equipment, you know, laser tube processing, routers, knife cutting, punching, multi-process machines. Obviously, you know, laser, plasma, oxy-fuel, water jet, you know, your standard single process machines. We've been doing those for a long time as well. But it's very, very important to, if you're going to integrate, to have a system that can run all this equipment, because in order to really integrate and automate and do proper feedback to your business system of usage and work order completions and things like that, you really need to be able to run all this equipment. So SigmaNEST in general. So some of the main components of the SigmaNEST based system for programming is our advanced CAD importing for one. You know, we import from all the latest CAD systems, you know, from SolidWorks to Autodesk Inventor to CATIA, Creo, NX, you know, you name it. I mean, we have integrations and the ability to import CAD models from most of the popular design systems that are out there today. And this is very important, especially in a world of you know, keeping track of files and you know, maintaining integrity of models and things like that. It's important to be able to go direct to the CAD models instead of, you know, going down to the DXF level or whatever it is that you have to use in that environment. You know, obviously the advanced nesting and the toolpath generation that I spoke about, those things are very critical as well. And every version that comes out in SigmaNEST, there's more advancements in these technologies that we've had since 1992. So, you know, if you can do it in a toolpath or you can look at it in a way of nesting, chances are we're doing it. Being able to, you know, advance nest on remnants and utilize the drops and things like that, and understand which drops are the most efficient ones to use and which plates are the most cost effective to use with the least amount of scrap, to make those decisions for you. The NC simulation, so you can see exactly what the machinery is doing, more with the routers and the bevelers and the punching machines and things like that. That type of simulation is critical to see the functionality that you're hoping for at the machine. And then obviously integrating to the shop floor, integrating to the office. SigmaNEST is really the heartbeat of that, to make all of this come together and work as a one unit. We also have a portfolio of other auxiliary products that can be added to the SigmaNEST solution, from SigmaTube, which is very powerful tube nesting software, where we actually can provide a plug-in even to SolidWorks and actually do the tube processing via the model without having to recreate the drawings or the parts or anything like that. Very, very up and coming process that seems to be gaining in popularity, these automated tube processing systems. And then even for Sigma DSTV, creating NC1 files directly out of SolidWorks with the use of SigmaNEST Sigma DSTV. That's a very nice utility to break those models down and create NC1 files automatically. There's a lot of companies out there that are in need of a solution like that. Another up and coming solution that we're providing is Sigma CTL. It's a cut to length nesting system that houses standard inventory of all the types of structural materials and things that you would be processing across your saws and or, you know, beam lines or whatever. But it's going to maybe nest, find all the correct stock, use all the correct stock in the most efficient manner, produce reports that tell the operators how to process that material, and also update work and inventory as well within the system. So Sigma CTL is definitely a product that's going to be gaining in popularity the more versions that we come out with. Bending software, obviously, if you're going to provide software for a laser, you need to be providing software for a brake. So our bending software is quite popular as well. And it's a really nice offline programming solution for most of the brakes that are out there today. So definitely check that out if you're in need of brake software as well. Developing for HVAC or, you know, boilermaker type applications for unfolding and creating these parametric shapes, and also just general unfolding. We have a real nice unfolding package that can be added as well to the SigmaNEST system. So shop floor management, this is something that I feel very strongly about. It's definitely changed the game with the use of programming software. As I mentioned earlier, with nesting and programming software, you were just quickly able to get your nests and kick them out to the floor. But then what is really the question? Then what happens? You know, operators have to figure out and decipher what parts go with what work orders and what parts go where. You've got to be able to find these nests and programs that are scheduled on the machines. You know, so it just becomes a a much larger task to find all of this stuff and to manipulate this whip that you've got on the floor and communicate this data back and forth. So these products here with Color Offload and Load Manager, Color Offload and Load Manager are two of the products I'm going to highlight when I do the live demo here in just a minute. Those are, you're going to get to see those, how those work firsthand. And then shop floor data capture for actually updating work and stuff off the break and other processes that you might have in your shop is also something that we're working very closely with to provide solutions for that. I spoke earlier a little bit about business system integration. That seems to be the next step with all of this. The programming and nesting obviously is a given when you buy one of these new pieces of equipment. And they want to import parts and get work out to the machine and get it cutting and achieve great yields with their material. And we've been, like I said, that's been just as important back in the early 90s when all this started. So, but the big game changer now is integrating all of this to the business system, keeping track of this, no double inputting of data, presenting this order data in a fashion that makes it easy to see and put these nests together and prioritize work and get it out to the floor quickly. And SimTrans is a big part of that. And I'll talk a little bit more detail about that in a minute. But we also go as far as actually producing our own MRP system, our own ERP, MRP system that has SigmaNEST and all these tools embedded in them into one complete system. So it really depends on what you're looking for, but we can kind of, walk into this integration from a few different angles, depending upon where your company is at and what you're looking to do. But I would say the overwhelming majority of our customers are, they've already got an MRP, ERP, and they use SimTrans to bridge that data between their system and our SigmaNEST databases. So that's really the more popular one right now. And then obviously another one that's becoming overwhelmingly important is accurate quoting. The quoting stage of creating jobs is normally a lot of guesswork in the beginning, a lot of Excel sheet calculation. That's just the way that places have been doing it, business like this, for some time. Well, now with all the information that we have available to us in SigmaNEST, cutting machines, feed rates and speeds and the price of material and net weights of parts and scrap calculations included and the full nesting gamut of providing a complete report on how much plate's actually being used. Our quoting has become a lot more accurate and a lot more easy and a lot more automated than it used to be. So that is a big topic moving forward to streamline these processes altogether. So it's kind of stepping back, I'm going to talk about SimTrans, SigmaNEST, Load Manager, and Color Offload. Those are kind of what I'm going to be presenting to you here. And as I mentioned, SimTrans is really the data broker between the two systems, between the MRP, ERP system, and SigmaNEST. It basically synchronizes the data between the two systems, and it can be used to transmit data into SigmaNEST and also feed data back to the MRP, ERP system. So it has a very important job, and it also facilitates a lot of data between Load Manage and Color Offload out on the floor to tell people what's going on with scheduling of the machines and the completions of the work order statuses and such. So very important. So kind of what does it look like without SimTrans? This is kind of, a lot of companies are used to this, but my story is, and I'll tell it real quick here, not to bore you, but like I said, I worked at a large steel service center. We had about 6 large plate machines. We ran 3 shifts a day. I would come in 7 or 8 o'clock in the morning, and I would walk into a stack of work that I would have to sort through, figure out, and program for. So I would culminate all this stuff as best I could. I would combine some jobs that I could after I had several other stacks on my desk after I've sorted through those and kind of prioritize these things. And I'd put the nests together. So I would walk out onto the floor and I would deliver the nest packets, if you will, of the equipment, usually between 9 and 10 o'clock in the morning. And I thought that was pretty good with the volume of work that we had to process. And I used a couple different CAD/CAM systems during this time as well. So by the time I got done distributing all this work and finished the nests and whatnot, you know, between 9 and 10, I would come back up into the office and pick up the next stack of work. Well, it was just another stack behind the next stack. And, you know, what I wasn't able to see is in the next stack was more 1/4 inch, more 3/8 parts, more hot work that I just sent out and created nests with, you know, an hour earlier. Well, what I'd done then is they've already started on these plates out there. So they're taking that 1/4 inch plate and they're cutting that program only to create a remnant that they're going to have to put right back up on the machine probably that afternoon, because more 1/4 inch work came in that I wasn't aware of, and I didn't get the paperwork in time, and I wasn't able to sort through it and include it into that nest that I'd sent out to the floor. So that creates not only just an issue for me in programming, but it creates an issue in the floor. They have to putting more plates on the machine. They're going to having to run more programs on the machine, more setups on the machine. They're having to move that plate around more in the shop than need be. And a lot of times that remnant never makes it back to the machine. You know, the guys just start out with another fresh plate, or it gets lost in the shuffle. So there are a lot of ramifications downstream that aren't obvious and upfront if we don't find a way to streamline this process from the business, the order entry, the order system into the programming system. And that is what we use SimTrans for. So you can see me on the left. I have a little more hair than that, but you can see that it is gray now. But I was shuffling through paperwork like that, trying to put all this together in a timely manner. Whereas on the right, if I was connected to my MRP system with SimTrans, I could see the work, I could see what was ordered, I could see what was completed, I could see everything that I needed to do, even if I didn't have the work right there in front of me as far as paperwork was concerned. So I could, right to the very last moment I'm ready to send that nest to the machine, I can make sure I've got all the work that is required during that time span that I'm looking at, or whatever priorities I'm looking at. So not having SimTrans may not feel like it's a big deal, because that's the way people have been doing it forever. But I can tell you the next level, the next refinement, if you will, in the process to be competitive, to, you know, have less expense, less waste, is the usage of SimTrans. So, and all of this really contributes to, you know, what we like to call our continuous data flow. I mean, all of our applications that we have now run off of a central database inside of SigmaNEST. They're not all separate databases, it's one database. So all of these products work together, they all work in unison, and it is a really nice system when implemented, depending upon what your current needs are. So really, we're just out to really help manufacturers provide better solutions and streamline their processes for the competitive market moving forward. So I'm going to go into the software now and not bore you anymore with the PowerPoint. So I'm just going to switch over here. And like I said, we're going to talk about SimTrans, SigmaNEST, Load Manager, and Color Offload. We have other applications and other auxiliary products, but these are the kind of the ones we want to focus on today. So I'm going to move over to pieces of the software here. So this first application that I want to show you and talk about a little bit is SimTrans. This is you know, kind of what I was featuring as kind of the new highlight or new thing that we should be looking at moving forward with the higher volumes, you know, faster equipment, things like that. This is SimTrans is really kind of the next level for integration. So with SimTrans, it's an application that really runs in the background. It's unattended and it monitors. It just monitors a folder from your MRP ERP system and waits for the work to show up. And it can run every minute of the day, an hour, every hour of the day, once a day, however you want to process your work. It can also handle different districts. So in other words, if you have you know, one MRP ERP system running a couple different shops, we can actually facilitate the work going to those other shops' programming systems as well. So it's not just a singular type scenario. But it has all kinds of reporting capabilities. It can tell you if there's any errors that come through the system, or if there are any stoppages in service or anything like that. It can send out emails on a regular basis just to make sure that you're getting notified if there's any changes in the functionality of the system. The event log is really what I look at. These are all the transactions that come through in SimTrans. I mean, SimTrans can do everything from bring in work order data into SigmaNEST, bring in inventory data into SigmaNEST. It can do repeat orders. It can do change orders. It can do a lot of different functionality. It can actually go into engineering and grab the CAD data from certain directories to create the parts automatically to be processed into SigmaNEST. And obviously for all the work order information, it can go to the correct areas where those part files or DXFs or solid models, whatever, are located to create those parts automatically as well. But once again, it sits in the background and just does the data brokerage between the two systems. So there's no one needs to really utilize the system. It really functions on its own. And I'll visit this once again so you can see some of the updates. But now we're going to move on to SigmaNEST. So inside of SigmaNEST, this is the main screen of SigmaNEST. This is where most of all the programming is done. We're going to switch a few different hats today during this presentation here. So right now I'm wearing the programmer hat. So like I mentioned to you before, with the stacks of work and everything that I come into in the morning. Well, now with SigmaNEST, I can look and I can see it's got a workspace similar to, you know, the feature tree and whatnot on the left, similar to what you might see in SolidWorks, some of the other new applications. We have a full featured CAD package. You know, I used to do, you know, all the drawing with SigmaNEST, and we could do anything from scratch on a paper napkin to replicate, you know, 5-page blueprint layouts if you need be. But we're not out to replace the CAD systems that are out there today. This is just really a lot more for, you know, any corrections or quick changes that we might need to make. But I can tell you it's a very, you know, full functioning CAD tool. You know, it's got standard shapes and things like that, which you can go in and create parametric shapes. I can create a 12-inch ID. I can put a bolt hole pattern on 16 inches. I can do, you know, 1/2-inch holes and put 23 holes in it and quickly make a part or cost it out or create a quote, et cetera, if I wanted to go ahead and present a nesting. So nice to have some of those tools in there. We also have a tools help tab. This is really for configuration of the product and to communicate with our support and do upgrades and updates. Most of our support with SigmaNEST is done via the web, where they get on and take control of your system, and they can go in and help you and do, you know, any of the functions that you're doing in your environment. We have pack and send sessions where you can actually pack up your entire total SigmaNEST environment and send it to our technicians, and they can open it up as if they're sitting right there at your desk and resolve it with all the settings that you've presented. So there's some nice tools in here. But getting back to the main workspace of SigmaNEST, obviously the importing capabilities, you can see, you know, from CATIA to AutoCAD drawings to images to NX to Rhinos. I mean, the list is quite long, and we've got quite a good team, 3D team that put together some nice import utilities inside of SigmaNEST. Then we have a parts database that you can house your parts. When parts come into SigmaNEST, they actually have a life. They're not just a DXF pull every time you want to make something or whatever. So they come in, they have a life inside our software. You can open them up, you can see what machine they were processed on last, different revision numbers, all kinds of different data. Each machine that processes these parts inside of SigmaNEST has automatic lead in and lead out technology, where based on material type and thickness and that process itself, it can automatically set up the lead ins and lead outs and things that are important to you in a programming environment automatically based on a few different criteria. So that's very nice to have that capability, but it's got a really nice parts database. Also sheets inventory. You can see, you know, coils and remnants and prime stock sheets and things like that. Right now it's sorting for 1/4 inch, but you can see here would be just an inventory of my sheets that I have. This would be mimicking my ERP or business system. What's nice about this is I can look at remnants, and in these rems you can see, it's not just some square inches in my MRP, ERP, or linear inches to be used. It's actually got a life, and you can see it's part of it's cut out. And from the programming side, you can really be more efficient about what remnants you want to select to use, and really use all those up to reduce your remnant stock. And there's all kinds of nice features within the inventory to actually keep track of test reports and pictures of, scaly plate or whatever the case, or test reports, costing information, whether these are reserved, things of that nature. There's a lot of features built into our inventory system. But that's that particular button there. Then you've got the work order system. This is one that I feel very strongly about. Once again, this data is being monitored real time by SimTrans. As I'm working, data and work orders are being pumped into this system and show up in the list. So you can see on this particular work order, for example, it's not started, but there are several parts in this work order. It could be different material types and thicknesses and go on different pieces of equipment, etc. These can all be the same material type and thickness. In quantity, you can see who they're for, and you can have different internal due dates for these work orders, but this is all data that would be pumped in from, like I say, your business system. But it's in a view for the programmer where he can really make a lot of decisions. And this information here can also be shared in this view inter-officely as well. So we can make the screen like this show up where they can actually see the status of work orders, and they can see what parts are on order, what parts are in process, how many are completed, and how many are remaining, what their due dates are. There's other data that can be added to this, but just to kind of give you an example. So that's kind of the work order screen. Then obviously you go into nesting and some of the features for general programming. So what I'm going to do here is I'm going to simulate just going in and programming some work. So I'm going to go in and set up a new nesting task, and I'm just going to go in and look at my work order screen, see what work I have to do for today that the system's put in there. So I can see I've got all kinds of work. Now what it's done is it's broken these individual parts out. You can see these are all work order 2004, but it's broken all these parts out individually because they might be different material types and thicknesses. So I might end up with a lot of 1/8 inch material that's over across a bunch of different work orders. And this is how I'm going to really maximize the plate and maximize my delivery times and requirements in the shop. So as a programmer, when I look at this, I want to go ahead and say I want to tag all of my work from today till, say, Friday. And I want to look at all my, say, 105 cold roll that I have for that. So I can hit OK. And now the system will go ahead and tag all that. And it's going to run across several different work orders. So as soon as I hit OK, it's going out and grabbing all the appropriate parts to fulfill those work orders. I don't have to go looking and importing the DXF files, finding the parts, bringing them in, trying to, wonder if I got the right quantities and things, thumb through the paperwork and start filling quantities in. I don't have to do that anymore. The system did that for me already. So I've got a piece of mild steel here, as you'll see. You can see I've got one piece of mild steel that was in with the cold roll, but it warned me. So it keeps track and gives you warnings of what's not right as far as material type, grade, and thickness. I'm just going to leave it in there because it's a mild steel part. So I've got my parts. Next thing I'm going to do is I'm going to look in my inventory, and I'm going to see what 105 material that I actually have. So I'm going to look at my prime sheets, and so these are, it automatically filters your entire inventory database out to tell you what parts and things that you've got. Back up here a second. So there's my 105. I'm just going to copy these guys across again and then look at my sheets. Oh, that's right, because it wasn't just 105. It was 1/8 inch. So I'm going to remove that. It got confused. So I'm just going to go with the 105. So now if I go in my sheets listing, I can see that it's sorted out my 105 material. So I'm going to use these 25 sheets of 60 by 120. I've also got 48 by 96 in here. I could also select those. but I'm just going to select these for now. So when I do that, it's going to run the 25 sheets of 60 by 120 for this particular job. Now in here as well, we also have the ability to have it tell us, like if I would have selected the 48 by 96 and also some rims to use, I could say, give me best sheet mixed. So it'll run through, do the nesting analysis, and it might say, use 2 60 by 120s, 1 48/96, and these rims for this job. Or if I use best sheet fixed, it will look through all of the different sheets that I've pulled over and say, out of all these that you've pulled over, the 48 wide is the most efficient to use for this run of parts. So you can kind of see the power that's built up in that. So I've got my sheets, I've got my parts, and then I can look at my nesting task parameters if I'd like to. Most of this stuff is set it and forget it by machine. Right now we're on a laser, but if I switch to a router, all these settings would change to my router settings, and I would be able to just go ahead and run without having to totally reset anything up. So that makes it very nice. This is also defaulted by material type and thickness, so any part clearance spacings or anything like that is all defined by material type and thickness. So very, very powerful, advanced default settings as far as that goes. So I'm going to go ahead and just hit OK, and now I can either manually nest or automatically nest. I'm not going to spend much time manually nesting, but I'll just show you, for example, say I, want to nest. Let me grab a little bigger there for you. So I can grab, different parts. I can use a bump mode, and now it'll bump it up against the edge of the sheet using clearances that I specify. I've also got rotation, different things I can do. I can go grab other parts, and, bump them in, move parts around. I can also come down and just say I want to right mouse click and say just auto nest just that part, and it'll go in and it'll auto nest that part. And I can come in and right click on a different part, and I can auto nest that part. Some of the other nice features in here as well. Say, for example, I've got these parts here, and the other thing that's nice about having a CAD system is, let's say, for example, I had these parts nested, and I actually needed to go in and I realized the smaller hole on these parts here on this part is going to be milled instead of being cut. So what I can do is I can go in here and I can say edit part geometry, and I can go in and actually change different things, but I'm just going to delete this hole because they're going to go ahead and mill that instead of going ahead and processing it. I'm going to close this back up and rebuild the part, and now all the parts in the nest and all the parts like it and all the other nests that it's in this particular nesting task will be updated to this particular part. So that's kind of the reason for having the CAD tools in there, but you'll notice I never have to back up. I never have to go backwards in our system, change things and redo work. Very, very important when you're processing a high volume of work. So I could leave this like this and continue auto nesting all these parts around it, but I spent enough time on manual nesting. I'm just going to go and hit auto and re-nest these parts. So now it's going to go through and nest the parts. Here's sheet 1, and I can go ahead and look at both sheets or 10 different sheets that I want to do, and I can drag parts from sheet to sheet. You can see we've only used half a sheet on this particular side here. So going back to just a single sheet view, now I'm going to go through and I can look at the reports on these if I want to. I can print and preview some of these reports. These are standard inside of SigmaNEST. So you can see here's the first sheet, the second sheet. It gives me scrap percentages. This is a very good report for procurement, for bidding jobs or getting material ordered for jobs, because it kind of gives you exactly what you're going to need to run this job. Usually they're larger than this, but in this example, we would need these 2 sheets. So nice internal report. This is more of a report for the operator. Also, you can look on here as far as the work orders that we selected. It's basically telling him if it's only started on this particular sheet or if it's completed on this sheet. That way he knows he can go and package up a part or parts that are coming off of a single sheet, or if he should wait until this is completed on the next sheets coming up. So there's information in here, and all of our reports are user definable. They're customizable. It comes with a report maker. They can go in and change these reports to pretty much, you know, look like whatever they want. But it's pick the right sheet name, where it's located, the heat number, everything they need to be looking for this 5x10 material. Also, labels, we can emulate barcode fonts, QR codes, whatever you want to put in labels, those can be automatically created as well. So that's a nice feature to have there, and usually what goes out. Now, when we go to the next step and we actually create the toolpath sequence, a lot's going to happen here real quick. And this is because I picked a laser machine. Because I'm going to laser cut this, it's going to be different, say, than if I was going to router out this. Because if I was going to router this, and I picked a router machine, a whole new set of circumstances or features would be set as default. Because I picked a specific laser, these are the features I like to use on this particular laser. So in there, we're going to talk about collision avoidance. This is a safety feature. I mean, these machines are moving way faster than they used to move, and automation is usually connected to these machines with towers and things like that. So crashing the head is not something that anyone gets very excited about. And usually it's very costly and it shuts things down, and we just don't have time for that. So we want to have features in here that are set up to run this most efficiently and safely as possible. And collision avoidance or part avoidance is one of those ways. So this will actually move the lead-in line around the part, or around the contours, so that we don't cross over contours that we've previously cut. We also have profile destruct. So this is going to slice up and dice up internal scrap or internal contours, so we don't have to create tabs and things like that, so in case these might tip up. So I want to chop up the scrap. I also want to create remnants automatically off the sheet if they're within a certain amount of material. I might have maybe 13 inches wide is the least I want to go and consider it usable scrap. Well, I can tell the system that, and it will either crop it if it's more than 13 inches, or it'll amortize it to scrap if it's less than that. So there's different things in here that we can do as far as that goes. And I want to create the remnants. I can have it actually etch the remnant names on there. I can do a lot of different things from this area here. Common line cutting and whatnot, we're not doing that with this laser, but we're doing automatic tabbing, things like that. We've got different tabs. We have recessed tabs that we utilize. I mean, we're not just into nesting and programming. We've actually developed special tabs that reduce the need to do grinding. And I can't tell you how many shops I go into right now and find that, you know, they've got 6 grinders behind a screen, behind this big automation grinding parts. So very critical that to have special tools that help facilitate all of this. So we're going to program these parts, this nest. You can see the red lines are cut lines, the white lines are rapid lines. Sheet 1, sheet 2, and we've created a remnant. So now I'm going to go ahead and post-process these programs. Here's 5 and 6. This is the program names. You'll also see that we're also posting these for 3 different lasers, and I'll tell you why that's important. We're post-processing this for an Amada, post-processing for a Cincinnati, and for a trunk. We can save the e-reports out. All the reports in SigmaNEST can be saved via PDF and sent to a location. So we're posting these out. We'll then get a successful posting. So that's a success, so I can say I'm done. So right now in SigmaNEST, as a programmer, I'm finished. So I'm going to go workspace, new workspace, clear it off, and away I go. So, but if I look at the work order screen real quick, you can see now I've got 37 of these parts for nitrogen are in process. 14 of those are in process. 109 of these are in process now. So I've got work that's been now created. Now I'm going to switch hats and go out to the floor. So I'm in Load Manager now. This is a scheduling tool for scheduling the equipment. So either Operations Manager or somebody else can do the scheduling on these. So I can go ahead and grab this particular program and I can drop it on the appropriate laser that it's going on, or I can also drop it on a different laser as well because they're compatible. Now what you'll see is you look at the time on this one, look at the size on this machine. If I drag it over to another machine, you can see the time on this is different. We've calculated the time differently on these different machines. and therefore we know how to schedule this. So what I've done by scheduling this now, I'm going to switch hats again, and I'm going to move out to the operator. The operator uses a product called color offload. Now this work just showed up on his color offload screen. So in color offload, he can visually see the actual nest that he's going to run. He can see all the work orders based by color. He can also see next processes for press break based on color. He can do a lot of things visually here. It makes it easy for him to see. So he can go ahead and start to run this program. And this one's on the HK. And if I go back in the load manager screen now, if I'm the operations manager looking at this and I refresh the screen, I will see that it'll turn green. So all the programs that are green are the ones that are currently running at the machine. So back out at the machine again, if I'm the operator, I can do a few things here. I can say I've stopped and finished this job, but say for example, this part here was rejected and it had damage in the cutting process. So I can go ahead and scrap that part. I can say, okay, and it will report all that back to the business system and to the programming department, so that's the next thing to be cut. Now, if I look over on the Trump machine, there's the work for the Trump machine there. So I can go ahead and I could do things like swap sheets and pick up a different stock size sheet out of my inventory to use the correct sheet if I want to. I can edit the remnant if I need to, but I'm just going to go ahead and actually just update this to say that that job is done. Now, if I go back into SimTrans now, and first of all, in Load Manage, all the programs are now gone because they were completed. If I go back into SimTrans now, you can see that it's keeping track of things. It's updated those programs. We've rejected a part on program number 5, and it's moving, it's monitoring these things in the background. So inside of SigmaNEST, I go back to the program review and I look at the work orders, I can see that now that work has moved into the completed category. But under Night Train products, you can see I did 36 parts completed out of 37, and I can see they're partially done. So if I get a call from Bob from Night Train and he says, hey, Brian, are my parts done? I can actually come in here and open it up and I can say, Bob, all your parts are done except we've got one more part we're waiting on, and it's this part right here. That is the part that we rejected. But all the rest of this parts, I can see they're done. I didn't have to make a phone call. I didn't have to walk out on the floor. I didn't have to look for paperwork. I didn't have to do anything as far as that goes. I just watched the screen, watched it all happen in real time. So if I'm the programmer and I'm back in SigmaNEST and I want to create a new task and look at my work orders again, and if I'm looking at 105, for example, because I think that's what we rejected, I'll see there's my one part that I got to include in that next list. So I'm already out of time right now today, folks, but I really wanted to spend a little more time going in and out of this. But you can see here through this example that all these products are connected. All of them speak to each other, and all of them provide the essential information that you need on a day-to-day basis, from your business system to programming, from programming to scheduling, from scheduling to your operator, from your operator back to all those people back upstream, and updating your business system in the end. All of these things have a very important part of moving that bottleneck out and creating more efficient processes and savings in the organization. So I'm going to have to leave it at that for right now, but hopefully we've generated some questions and that I can come back and answer, and we can talk about this in some greater detail.
Brian, I just want to thank you one more time for being here with us today.
Thank you, and thank you for having me. Hopefully it was useful.
It definitely was. Thank you. All right. Thank you again, everyone, for attending, and have a great day.